This is the third edition of the chapter Limits and Derivatives, and today we are going to discuss a very important topic. Now, before we go on to the discussion, let me take few problems from the previous topic that we have completed, that is the standard limits, and let me solve a few problems. Let us take the first one. Limit x tends to 0, e to the power x minus e to the power minus x by x. Now, limits of exponential and logarithmic function are not part of class 11 syllabus, they are in class 12 rather, but let me just complete it. Why? Because we all need to remember is the standard limits, and once you remember the standard limits, then it becomes very simple for you to work with when we take up this particular problems once again. So here in this case, the standard limit which we are going to make use of, that is limit x tends to 0, e to the power x minus 1 by x, that is equals to 1. So this is the standard limit which we are looking for. So we have to see we have to find a situation where we can make use of this standard limit. So let me start. So now e to the power minus x can be written as 1 by e to the power x. So therefore this one, which we can write as 1 by e to the power x. So therefore, after writing and taking LCM, we get something like this: e to the power 2x minus 1 by x e to the power x. Then we can separate out the two factors. One factor is 1 by e to the power x, which is not contributing in the limit, so I can take it out. And the other part is e to the power 2x minus 1 by x. Now limit of 1 by e to the power x, putting x equals to 0, that is 1, so it doesn't contribute anyway, so it just goes out. And here e to the power 2x minus 1 by x, let me multiply and divide by a 2. So therefore this is what I get: 2 into limit x tends to 0 e to the power 2x minus 1 by 2x. Now obviously this limit is 1 because e to the power something minus 1 by something, it is in that form. So therefore this limit becomes 1, and so your answer becomes 2. Simple. Let us move to the second problem, problem number 2, or chronologically minus 1. Limit x tends to 0, root over of 1 plus x minus 1 by log of 1 plus x. So I know that I have a radical sign, so I have to rationalize it. But before that, the standard limit which we are going to make use of here, that is limit x tends to 0, log of 1 plus x by x, that is equals to 1. So this is the standard limit which we are going to make use of. So we have to find where we can use it. So now let me first do the rationalization. So if I do the rationalization, this is what I have. So root over of 1 plus x minus 1 into root over of 1 plus x plus 1. If we multiply, it becomes 1 plus x minus 1, and it gives you only x. Then we can separate out two limits, that is limit x tends to 0, 1 by root over of 1 plus x plus 1 and x by log of 1 plus x. Now in the second one, in this one, I can directly put the value of x as 0. So if I put the value of x as 0, it gives you half. So let me just keep it outside the limit. And this particular x, I can take it down and it becomes log of 1 plus x by x. So therefore, the whole situation becomes something like this: half into 1 by limit x tends to 0, log of 1 plus x by x. Then limit x tends to 0, 1 log of 1 plus x by x, it becomes 1. That is the standard limit. So therefore your final answer becomes half. Fine. Now let us move to the third one. The third one is evaluate limit x tends to 0, 2 to the power 3x minus 3 to the power x by sine 3x. Now here the standard limit which we are going to make use of, that is limit x tends to 0, a to the power x minus 1 by x, that is equals to log of a. Now obviously a has to be greater than 0, because if a is not greater than 0, then this particular formula won't be applicable. A log of a won't be existing, so therefore I must ensure a is greater than 0. So now let me do a small manipulation. What is the manipulation? Let me add 1 and subtract 1. So by doing so, I have 2 to the power 3x minus 1 minus of 3 to the power x minus 1. Fine, by sine 3x. So now let me separate out the two factors. If I do, this is what I get. 2 to the power 3x minus 1 by sine 3x minus of 3 to the power x minus 1 by sine 3x. Fine. Now let me divide both the numerator and denominator in both the cases by 3x. This is what I get. Now let me do something. Let me separate out the limits as well, because limit of a quotient is same as quotient of the limit. So this is exactly what I get. Limit x tends to 0, 2 to the power 3x minus 1 by 3x. Limit x tends to 0, sine 3x by 3x. And 1 by 3, let me take it out. So limit x tends to 0, 3 to the power x minus 1 by x. And limit x tends to 0, again sine 3x by 3x. Now sine 3x by 3x, we know that limit is 1. And 2 to the power 3x minus 1 by 3x. So 2 to the power something minus 1 by something, that gives you log 2. And again 3 to the power x minus 1 by x gives you log 3. So therefore your answer is log 2 minus 1 by 3 log 3. Right? So these are the problems that we have. Now definitely these problems doesn't come in class 12 as well, but we will be requiring them to solve few advanced problems in class 12. So it is better that we know it now, so that we can make use of this as a tool in our next class in class 12. Now let us go to the topic which we are going to discuss today, a very important topic, that is the definition of derivative, which is also known as the first principle of derivative. Now this is basically giving us the idea that what derivative actually means. Now obviously there are different definitions or different aspects of derivatives, which are again to be discussed in details in class 12, which is completely a topic in itself. So we are just going to give the definition and the formula, and we are going to solve problems. So we are not going to talk much about what derivative means or what it does. I'll just give you a small idea of what it actually means. Now, before we go into the discussion, let me just give you a small idea of what actually derivative means. Derivative is basically, if I have a curve, say this is a curve I have. I don't know what curve it is, so let this be y equals to fx. Now, this is your x-axis, this is your y-axis, this is your origin. So this is the curve you have. So derivative at any particular point is basically, it gives you the slope of the tangent to that particular curve at that point. Also, derivative does what? Derivatives gives you the rate measure of anything. Rate measure of anything in the sense that how much a quantity is changing with respect to another quantity at any instant. For example, if I have velocity can be considered as rate of change of position with respect to time. So therefore, when I have the velocity, so velocity can be written as the rate of change of time with respect to the position. So if I consider position as r, so velocity is pretty much to be considered as derivative. Let me just rewrite it once again. It is to be considered as derivative of r with respect to time t, and therefore we write this as dr dt. Now obviously again acceleration is considered to be rate of change of velocity with respect to time, so therefore we write that as dv dt. So basically derivative does two things. It gives you the slope of the tangent to any particular curve, and also it gives you a rate measure of any physical quantity with respect to another physical quantity. So all these particular things are to be discussed in details in class 12, so I am not going deep into these ideas. Let me just give you the formula and let us solve the problem. So that's all we have in class 11. Now if y equals to fx is a function, then the derivative of fx is denoted by dy dx or f dash x, which I think you already know from your physics classes, and is defined by f dash x, that is equals to limit h tends to 0 f of x plus h minus fx by h, provided the limit exists. Now obviously, if we know that whenever we are talking about limits, limit has to exist, it has to give me a finite value. If it doesn't give me a finite value, then there is no point in finding that limit. So therefore, if this particular limit exists, then I say that whatever the value it gives me, that value is called the derivative of fx. Now obviously there always remains a question that how this formula comes and why it is so, which is once again a topic of discussion in class 12. So for timing, let us know that this is the formula which we have. Now, and obviously if you are interested enough to know what it is about, then you can just go and check on different videos where it is exactly showing you the proof of this particular formula. Or you can also ask me, I can send you the link of my class which I have taken in class 12 discussing this particular thing. But anyway, not of much importance. Now this is basically called the first principle or definition of derivative. Now also there is something called derivative at a point. Now previously it was just derivative in general. Now let us discuss what we know as derivative at a point. So the idea is almost the same. So if I have a function and I'm trying to find the derivative of the function at a particular point x equals to a, it is denoted by f dash a. Obviously, instead of f dash x, it is denoted by f dash a, or also dy by dx within bracket in the subscript x equals to a. Then it is defined by, pretty obviously, f dash a is equals to limit h tends to 0 f of a plus h minus f of a by h. Now instead of x, I am just replacing x by a. So it is going to give us a value in the form of numbers. If I would have had x, it would have given me an expression, and as I have a value a, which is going to give me a number. And alternatively, we have another formula, that is f dash a is equals to limit x tends to a fx minus fa by x minus a. So you can make use of any of this formula, whichever you want. Now choice is yours, but I would always suggest to make use of this formula. This is a general formula which is going to remembering one particular formula will help you solving the problem easily. You can always make use of the second one anyway. Right? So all these formula works only when the limits exist. So that's it. That is all the theory we have. Now let us take a few problems and solve. The first one, using definition, find the derivative of fx equals to 3x at x equals to 2. So this one is a problem based on derivative at a point. So let me just show you how to do this. So derivative at a point means, again, let us remember what was the formula. So this was limit h tends to 0 f of a plus h minus fa by h. So therefore, what is a here? A is equals to 2. So my formula will become f of 2 plus h minus f of 2 by h. So therefore, this is exactly the formula. Fine. Now if f of x is given 3x, now always remember x is basically a variable. What is a variable? Variable is basically a container. it is containing some data. So therefore f of this container is equals to 3 times the container. So therefore whatever I have in place of this container, that exactly same thing will be replaced here. So therefore f of 2 plus h will become 3 times 2 plus h, right? So therefore f of 2 plus h will become 3 into 2 plus h, fine. And f of 2 is basically 3 into 2, that is 6. So now let us solve this. So limit h tends to 0. Now 3 into 2 plus h is 6 plus 3h, 6 and 6 gets cancelled. I am left with limit h tends to 0, 3h by h gets cancelled, and I am having the answer 3. So therefore the derivative at x equals to 2 is 3. Fine. So this is how we solve a problem. Let us take another problem so that the idea gets even more clear. Let us take problem number 2. Problem number 2 is, using definition, find the derivative of fx equals to 3x square plus 5 at x equals to minus 1. So therefore here the limit is going to be this, limit h tends to 0, f of minus 1 plus h minus of f of minus 1 by h. Now once again 3x square plus 5, so 3x square plus 5, so that is like 3 some box, that is square plus 5. So whatever I have in place of that box, I am going to put it exactly as it is. So here I have got minus 1 plus h, so this minus 1 plus h here will be replaced here also, minus 1 plus h. So the whole thing will be replaced. So therefore f of minus 1 plus h will become 3 times minus 1 plus h whole square plus 5, right? So therefore let me just put it. So this is 3 of minus 1 plus h whole square plus 5, and f of minus 1, if you just put minus 1 in place of x, I get 3 plus 5, that is 8. So therefore I have got 8. Now let me just break open the square term. So that is this, and 5 minus 8 is minus 3. So again on simplification, this is what I have. After removal of bracket, this is what I get. Now again 3 and 3 gets cancelled. I am left with 3h square minus 6h. h gets cancelled in the numerator and denominator. I am left with this 3h minus 6. Putting h equals to 0, my answer is minus 6, and hence f dash minus 1, that is equals to minus 6. Fine. So I think you have got hold of the idea of how to solve this kind of problem. Now let me take a different kind of a problem. A different kind of a problem means a problem where I have expression instead of numbers. So find the derivative of the following function from the first principle given fx equals to 1 by x. So no point is mentioned, not here it is not told x equals to 1, x equals to 2, x equals to anything. So I am just going to find the derivative of this particular function using first principle. So my formula is going to be this, f of x plus h minus fx by h. No point is there, so therefore I will just use it exactly as it is. So f of x plus h, once again f of x is given 1 upon x. So this is like f of some box is equals to 1 by that box. So therefore if I have x plus h here, I will write here also x plus h. Fine. So therefore this is what I get. F of x plus h is 1 by x plus h minus f of x is 1 by x. So now let me take the LCM and calculate. So if I take the LCM and calculate, this is what I get in the numerator, x minus h by x into x plus h. Now x minus h is basically minus h. So what happens? X and x get cancelled, minus h, and that negative comes out. And minus h divided by h and h get cancelled. Let me write that intermediate step here. So this is basically minus of limit h tends to 0 h by h into x plus h, or there is another x, h into x plus h. So this h gets cancelled, so you are left with minus limit h tends to 0 1 by x into x plus h. Fine. So let me just write that. This is what I get, minus limit h tends to 0 1 by x into x plus h. Now I can see I can directly put the value of h as 0. So if I put the value of h as 0, my answer is minus 1 by x square. So therefore I haven't written the final statement. So therefore f dash x is equals to 1 by x square with a negative sign, minus 1 by x square. Fine. Simple. Now let us move to the next problem, the last one, problem number 4. Find the derivative of the following function from the first principle. So here basically I have fx equals to cos square x. So again the formula is all the same, f of x plus h minus fx. So now I think we have already understood how to put the values. So this will become cos square x plus h minus cos square x into minus cos cos square x plus h minus cos square x by h. Now this formula, if you remember from your trigonometry classes, that this is basically your cos square b minus cos square a, that is equals to sine of a plus b into sine of a minus b. If you remember, this was the formula. This was one of those transformation formulae which you had. So therefore, applying this formula here, what do I get? Applying this formula, I have this sine of x plus h into sine of x minus h by h. Upon doing the calculation, I have something like this. So let me separate out the term. Sine of x minus h is minus sine h, or sine of minus h, that becomes minus sine h, and sine of x plus h becomes sine of 2x plus h. Now upon putting the value of h as 0, this is a standard limit, so this becomes 1, and in the first one if I put h as 0, then it becomes sine of 2x, and therefore your final answer is minus sine of 2x. So that's it. That is our class. This is how we solve the problems involving first principle, and these problems are a very big problem, not very big problem, a 4 marks question or 6 marks question depending on the difficulty of the problem. So I am pretty sure you will be able to do it. Thank you.